Kinematics, the V average equation. I am going to make a physics mini lecture for you guys today on the topic of another equation from kinematics. The equation says delta x equals V average times delta t, where V average equals V initial plus V final divided by 2, assuming constant acceleration. Usually in kinematics, at the introductory level, we do assume constant acceleration, so don't worry too much about that. What are the terms? Delta x, that's change in position. Delta is change, position is x. V subscript avg, that's average velocity for a process that we're describing. Delta t, that's the time difference or the time duration for the process. Over here we've got V initial, that's V sub I. V sub f is final velocity. Acceleration, of course, that's rate of change for velocity. We got a lot of velocities going on here, so it's important that we remember that velocity is the rate of change of position. And when we summarize our equations, what we have is change in position equals average velocity times change in time for this one. And over here we have average velocity is equal to initial velocity plus final velocity divided by 2 under conditions of constant acceleration, which again is our normal conditions. Why are these concepts true? The first one is true because it's a simple application of the idea that the change in amount of anything is the average rate of change for that something times the change in time. Another example that you could have for that is the change in the number of houses that you have in a new neighborhood is the average rate of change at which those houses are built times change in time. As for this one, the reason it's true is that when we have a constant acceleration process, it means that we have a straight line in our velocity versus time curve. There's no curvature here, it's just a straight line. And when that is true, we can always form pairs of points along that line which average out to giving you the same point that's between them as their average. And since the average for each of those pairs is that same point that's right in the middle of the line, that's also going to be the average for the entire process, the entire line. The last thing I want to say in this mini lecture is that these two equations can be combined to say that delta x is equal to V initial plus V final divided by 2, that's coming from the right hand side of this equation, times delta t. Essentially, we're just subbing out the right hand side for V average in this equation. And again, that's assuming our normal conditions of constant acceleration. Alright, I hope you guys enjoyed this mini lecture. That's the end. Up next is going to be a video on applications of this equation, and I hope you'll check that one out, and I look forward to seeing you there. Alright.